We're talking about the history of the atom. Our goals are to understand the history of the atom and the discoveries that led to what we know now. And for you to be able to describe the different models of atoms that we have. Last time we talked about the beginning, Democritus and his idea that there must exist a point where you can't break something into a smaller piece, and he called that the atomos. And John Dalton, who said the same thing but also added some new understanding of what chemistry was. We're going to continue looking at the scientists that led to new discoveries. So Dalton in 1800 saw the atom as a solid sphere. It was just a ball and you couldn't break it down anymore. It wasn't long after this idea was published that people really started to experiment more with matter. And one of the new technologies at the time was being played by a scientist named J.J. Thomson, who in 1897 was kind of playing with these things called cathode ray tubes. And a cathode ray tube is a glass tube where you remove all of the gases inside using a vacuum pump, and you put a small sample of an element inside in gaseous form. So you're taking most of the gas out, putting a little bit back in. And he was noticing some odd behaviors. First off, if you connect electricity to this cathode tube, you'll start to see a glow that traveled from one end, the cathode, to the other end, the anode. And this is what they called the cathode ray. As a matter of fact, this technology was what was first used in TVs to produce pictures. Now, what J.J. Thomson noticed was that if you were to apply another charge to the outside of the tube, so that one side of the tube was positive and one side was negative, you could bend that beam of light. And it always went away from the negative plate and towards the positive plate. So it was attracted to positive. And at this point, they already knew some things about electricity, and that electricity flowed from positive to negative or negative to positive, that opposites attracted. So this allowed Dalton to make a claim. Something inside the atom must be negative because it is being attracted to this positive plate. And he called this the electron, a negatively charged particle inside the atom. And this was huge because it refuted something that Dalton said. Dalton said that all atoms are solid. Well, J.J. Thomson has experimental evidence that there must be something inside. So we have to throw out Dalton's postulate, his first one anyways. We had to say that this was wrong. There must be something inside the atoms that is making it behave in the way that J.J. Thomson saw. And we have a beginning of experimentation with trying to discover what's inside the atom. And Thomson changed the picture of the atom. We went from Dalton's solid sphere model to what he called the plum pudding model, where he said that there are negative electrons scattered in an atom, kind of like raisins in a plum pudding. It's kind of hard to imagine plum pudding in the US because we don't eat it. So I like to imagine something like a watermelon, where the seeds in the watermelon are like the electrons, and the fruit, the red part of the watermelon, are all the positive charge. And from this, Dalton or J.J. Thomson opened up the gates for more experimentation.